Hey everyone, in the last video you watched, you learned about how to use function notation when we're working with equations. So either finding the value of x that gives you a certain function value, or finding the value of the function if I tell you the x value. What we're going to be doing today is we're still going to be working with this function notation, but we're going to be looking at graphs and then looking at some application problems, so more word problems that you might see on a test like the SAT. So the first one in number 1 is asking us to graph the following line. And we have the equation f of x equals 3x minus 2. So the idea here is really to notice that, or to remember that f of x is really just a replacement for y. So what we're really graphing is y equals 3x minus 2. Now, hopefully by now we all recognize that this is in slope-intercept form. So I know that 3 is my m, my slope, and negative 2 is my b, or my y-intercept. So when we're graphing equations in slope-intercept form, we know that we begin with the b. So this is a negative 2, and again that's my y-intercept. So I start on the y-axis at negative 2. And then I use my slope, or my m, to move. Now in this case my slope is 3, so it's 3 over 1. So I know that I can go up 3 and to the right 1. So from my y-intercept I go up 3 and to the right 1. Now remember, that's the same as negative 3 over a negative 1, because I know a negative divided by a negative is a positive. That tells me I could also go down 3 and left 1. So if I start at my y-intercept, go down 3 and left 1, all 3 of those points should be along the same line. So I'm going to use my straight edge now to connect those points. And so the function notation is just that. It's a different notation, but it doesn't change what we do. So if I look at number 2, again, I know that f of x is just different notation for y. So when I look here, now I have a slope of negative 1/2, and I have a y-intercept of positive 6. So I begin with my b, which is a positive 6. My slope is a negative 1/2. So then I'm going to go down 1 and right 2. So down 1 and right 2. And now I have 2 points on my graph again, and I can connect to make that line. And there's my nice straight line. All right, so that's how we use function notation to create a graph. What we're going to do next is going to be a little bit different. In problems number 3 through 6, we actually already have a graph of f of x. Now this looks different from the graphs we've been doing. We've been looking at graphs of straight lines. This one isn't, but it's going to help us work with this notation a little bit. So here's the idea. We need to use this graph, and in number 3 we're using the graph to find f of negative 4. Now, since this represents f of x, what's that saying is our x is a negative 4. So what this problem is really asking us to find is to find the value of y when x is equal to negative 4. That's what it's asking me to find. So I'm looking for a y value. So here's what we're going to do. I know that x equals negative 4. That means from the origin I take 4 steps to the left. And I know any point along this red line has an x value of negative 4. My goal now is to find out where this red line intersects the graph. So where do those cross? And I notice that happens at this point right here. So now I need to essentially know the y value of this coordinate. So this coordinate, we knew the x was negative 4. If I look up, the y value of that is 2. Since I was looking for the y value, my answer to this problem is 2. Okay, let's try a different one. I'm going to skip this one for right now. Let's look at f of 2. So again, I know my x value is 2, so I'm trying to find the value of y when x equals 2 now. So I'm going to go back to my graph. I know x equals 2. Let's say it's 2 steps to the right of the origin. So I know any point on this vertical line has an x value of 2. And I have to figure out where this green line intersects with my graph. And so if I look, that happens at this point right here. Now the ordered pair, that green point, I know the x value was 2. So I go right to and then down 2. That y value is -2, so that's the answer to that question. All right, let's do one more of those. Let's look at f of -5. So now x equals -5 is all the way to the left here. So this purple line, all the x coordinates are -5, and I can see right at the end here, I intersect with that graph. The ordered pair there is -5, and since I don't go up or down, the y value is 0, so f of -5 is equal to 0. So now we're going to take the same kind of idea and we're just going to flip it around. So again, we have the graph, and I'm going to move the camera a little bit here. Okay, we still have the graph of f of x, but now they're asking a slightly different question. This is saying to find the value of x. So now I'm looking for an x value so that f of x equals 0. So this question, remember we said f of x is 0. Well, f of x is really just y. So now I'm being asked to find the value of x when y is equal to 0. So we're going to use the same idea, except now we're looking for an x value. So y is equal to 0. I know y is equal to 0 anywhere along the x-axis here. So again, I'm looking for where, let's see if I can get this in better, where my green line intersects this curve. And I see that happens right here. Now the ordered pair of that point is 0, 0, which you can't see. Let me raise this up and see if I can fit this all in here. All right, so with 0, 0, now we said we're looking for an x value, and it just so happens here that our x value is also 0. Let's try another one. Here, they're telling me that f of x is -2, so I know y equals -2. So again, I'm trying to find the value of x when y is equal to -2. So let's see, y equals -2. I know from the origin I'm going to go down 2, and any point along my red line here is where y is -2. So if I look at my curve, it looks like it touches this line right at this point here. Now that ordered pair is, let's see, 2, -2. So the x value when y is -2 is going to be 2, excuse me. X is equal to 2. All right, so I'm going to leave 9 because that may be a good one to talk over to make sure everyone's understanding this. So let's look at 2 application problems really quick. And I think we'll just do one of these, and then again we'll leave one of them to go over in class. So number 10 says that if f of t, so this function that's named f, right? We said this was the name of the function in our last video, and t was our input. So I have this function named f, and it gives me the number of fish in a pond at any time t where t is measured in days. So as I'm thinking through this, I'm thinking f of t is equal to the number of fish in the pond, And this t is the number of days. Actually, it's, the day. So what they're asking is, if I know that f of t is the number of fish in the pond and t is the number of days, right, then what does f of 3 equals 8 mean? Well, I know the input was the number of days. So 3 must be equal to the number of days. 8 we said was the number of fish, so there must be 8 fish in the pond. So to put this all together, we would say f of 3 equals 8 means there are 8 fish in the pond on day 3. And so a lot of times these types of questions will be on the SAT. When we're back in class, we'll look at number 11, which is taken from there, and see how that relates, how this function notation is used in application questions. So make sure you've taken complete notes. Hopefully you've answered both of the questions in the video, and I will see you back in class. Thank you.